Hello YouTube, this is Umozo3. So we've been building up a pretty good understanding of regular expressions and meta characters. In the previous video, we almost moved on to a new topic, or we started talking about arguments and inputs to functions and how you could basically either have default values for arguments to functions, or you could potentially pass in arbitrarily many arguments to a function separated by commas, and then we could essentially parse those inputs as a tuple within the function and do things with that. So then essentially what we can do is review those things, but I want to actually go ahead and say another thing about groups that I forgot to say in previous videos about regular expressions. So I don't think it would hurt to do a few more examples and to try to familiarize ourselves one more time with the concept of regular expressions. Remember, we created two functions. Is match will return true if word to check begins with pattern. Is search will return true if my word begins or somewhere contains my pattern, right? That's the difference. Match, the pattern needs to be at the beginning. Search, it just needs to be somewhere in the string. So hopefully that's clear to you. So again, if we have group pattern, right? So we essentially have a pattern here with a bunch of groups in it. And again, we said groups are basically just a sequence of characters that we clump together into a parentheses, into parentheses. And then at that point, we treat it as one unit on which we can operate a meta character, or we can see whether or not that sequence exists within some overall string. So you can see a lot of groups here, right? There's a BC group, but there's also a C group. There's a DEFG group, right? There's a HI group, but there's also an H group. Okay, there's a J group, okay? KLM are not in a group. A is not in a group, okay? But it can still be matched within the string. It just doesn't belong to a group. So let's see what we mean by that. If we go ahead and say print of p.group, remember that that returns the entire string or pattern that was matched. Okay, so I probably could have, let's go ahead and run the console and see what the first thing that we get here. So that would just be A through M. Okay, so hopefully that's clear to you. And then if you say p.group of 0, again, this has the same effect as p.group. So this would just go ahead and return the entire string that was matched. And since it showed up at the beginning of the string, that's no problem. What if you had a W here at the beginning? Then do you think that would match? Then let's go ahead and run it. And then you would go ahead and say that there's an issue with that, right? So it would say that there's a runtime error, but then suddenly if you run it and you do have a match, then there's no problem. Okay, so that's why we need to have is match and is search, right? Is because that's why I made those functions, is because these functions from the module will throw runtime errors. And so what I do is I basically divert the program to just go ahead and say, well, if you were going to throw a runtime error, just return false instead. But anyway, so p.group and p.group of 0 have the same effect. P.group of 1 will return the first group that was matched. So that would be the BC. P.group of 2 will return the second group that was matched. So that would be the C. P.group of 3 will return the third group that was matched. So that would be DEFG. And p.groups will return a tuple with all the individual groups that were matched. So hopefully that's clear to you. You see a tuple with 6 elements corresponding to the 6 groups that were matched. So hopefully that's clear to you. And then we can also go ahead and look for, we can have this vertical line, right? And we said the vertical line can check for one character or one sequence of characters, or another character or another sequence of characters, right? So then for the first line, on 179, you can see a 6 or 7 in this sentence, right? So that would return true, but then you don't see Kelsey or Christina, so then that would return false. And so then I guess we would go ahead and run it, and you see the true and false, right? And then I guess I'm only printing one more thing here, and we talked about this arbitrary phone number, and we said basically \D is called a special sequence, and it'll match any digit, okay? And \uppercase D is the opposite. It'll match anything that's not a digit. So basically this will return true if this sentence, this string starts with 3 digits and then a hyphen and then 3 digits and then a hyphen and then 4 digits. But the problem is that it doesn't, right? What if it had started with it, but then it also had other characters? What if you had a ton of digits, right? And then you had a ton of letters and you just did something crazy? Well, now it would be true because indeed your string starts with this particular pattern. So hopefully that's clear to you. And then you can just do more examples, right? I have all kinds of examples, but we do want to go on to more content. So what if I say Kevin is old and Kevin rides his bicycle a lot? And then remember, if we say re.sub of R with Kevin, and then to replace would be Hannah, just an ordinary string, okay? It's not with R on it, it's just a string. And you could go ahead and do a replacement, right? And then you could do 2 replacements. So not only could you replace Kevin with Hannah, but you could also replace his with her, and you would just feed those in as patterns into this sub function, which takes 3 arguments. The first is the old thing, the second is the new thing, and the third is the overall string. So hopefully that makes sense to you. And then is search of X, and then this is a character class, right? So XY, is there, you know, either an X or a Y after an X? Well, yes, there is. But then if you have X and then either an X or Y after an X in this string, then you don't. So that would be true and false for these two things that are printed to the console. And I suppose I should probably go ahead. I'm just going to go ahead and write marker just so that we know where we're at with this stuff. I suppose it would have been obvious without that. But then I need to go ahead and close up these doc strings again. So I'm just going to go ahead and have 3 comments for a little 3 double quotes for a syntax thing. So now if we go ahead and run it, so then you get marker and then right. So the first thing is true because you have X and then a Y, but then the second thing is false, right? Because you can see X here, but then there's no X or Y, so there's no match, right? And then here it says Hannah is old, but Hannah rides her bicycle a lot because we did 2 substitutions. So hopefully that's clear to you. And then we can also check, what if we had something like consecutive 5s equals 0, and then we have basically, we have all these 5s, we have these digit 5s that are sort of running around in this sentence, right? And then we just want to basically, the goal is going to be to see the longest string of 5s that we have. How many consecutive 5s do we get? And so what we would do is we would just go ahead and see, we would want to see while re.search, you know, is valid, while that would be a valid Boolean. I don't want to say true because it doesn't really return true or false, but while it's equivalent to a true Boolean, while it's valid, right? So then if you printed the number of consecutive 5s, it would be 4, right? Because you can see that that's the longest string of 5s that you would see here, and that's the logic. And so that's an example of using regular expressions for that particular purpose. I also wanted to talk about named groups. So basically what we can have is we can say something like, if you have basically, we were seeing examples of groups, right, in our patterns, and we said basically that there were parentheses, right, and we had A, B, C in parentheses, for example. It turns out that if you add a question mark and then a capital P, and then you have basically this notation, right, you have this less than sign and then a name of the group, and then a greater, and then I guess a greater than sign, and then your group, whatever your group is, if you have that in a regular expression, then if you say match.group of name of group, then that will return that particular group. So let me show you what the hell I mean by that. So what we're going to do is we're going to comment out a little bit more stuff, but I'm going to want to uncomment something eventually. So here, what we'll do, I'm just going to go ahead and comment that out, but then we're going to want to comment again here. Okay, so essentially what we do is we have a pattern here, and then we have a word to check. And what you're going to do is you see a question P, and then you basically see this notation where you have this less than and greater than sign. And then in between the less than and greater than sign, you have a name of the group. So you can see there's a group here, and the group is ABC, but the name of the group is first, okay? And then there's going to be another group to the right of that. It's going to be DEF, but it's going to be called second, okay? And then there's going to be 2 unnamed groups, and then there's going to be another named group called last, which has the letters MNO, right? And then the last 3 letters are P, Q, and R, and those are in the pattern, but they're not in a group. And so now if you went ahead and called this object, right, think about this element, read.search of my pattern and my word to check. If you call .group of first on that element, then it'll look for the group, you know, who we called first. So that would go ahead and return ABC. So now if we go ahead and run this code, let's go ahead and see what will be printed here. So this will give you ABC, right? What if we said .group of second? Well, since we called, you know, the DEF group second, according to this question mark capital P, this notation, as long as you use this notation, it's called a named group, and it's a formal thing in Python. What if you say .group of last? So that would go ahead and give you this group here, just because of what we called it, right? And then if you say .group of 0, again, that returns the entire string that was matched. So you see A, B, C, D, E, F, G, H, I, right? All the letters down to R. And so that's why we have all those letters printed on the console. And then there's another type of group that I wanted to bring up real quick, and then we'll have to sort of move into other content. But what I wanted to say is that there's also something called a non-capturing group. So remember, with a named group, we have a question mark and then a capital P, and then the name of the group inside a less than and a greater than sign. If you just have a question mark and then a colon and then whatever your group is, basically that means that it's not accessible by group functions. And so it wouldn't break the numbering. And so, you know, typically with groups, we've been able to index individual groups. We've been able to say .group of 2 or .group of 1, right? But here, if you have a non-capturing group, it means that you wouldn't be able to access those groups by index position. So let me show you what I mean by that. What we're going to do is we're going to move down the commenting a little bit more. So I'm actually going to go ahead and comment this back out. This is a little bit tedious, but I want to show you what's going on here. So we have a pattern here. We have a particular pattern, and we're still actually going to need this word to check. So we still need the alphabet here. But what we're going to do is we're going to say, you know, we're going to call it again on read.search of my pattern or my word to check, or call it on read.match of my pattern and my word to check. But hopefully you understand the difference between those two functions in the re module. And so you say, if you say .group of 1, do you think it would return ABC? So let's go ahead and run this line of code and see if we would get the last group. So then I guess here, so we had the 4 from the number of consecutive 5s, right? But then the next thing that's printed to the console is .group of 1, and it says DEF because this is an example of a non-capture group. So we don't capture the ABC. It doesn't affect the numbering, and we don't really include it. It's just DEF, right? And then the second group that's numbered, that's counted, that's captured is JKL. We just skip over the GHI because we told Python that it's a non-capturing group. So hopefully that's clear to you. But then if we, again, just call .group, remember that returns the entire string that was matched. So everything from A up to R. So hopefully that's clear to you. In the previous video, we also talked about the idea that you could have default arguments to a function. So what I want to do is comment out a little bit more of this code. Okay, so how would I do that? So then essentially what I'm going to do is bring down these quotes here. And so basically what I'm going to do is I'm going to have a function that has 2 inputs, and one of them has a default argument. So t equals and then something, right? And so the question is, are we supposed to pass in something for t? Like, why is that written as an argument to the function if it already has a value? And so this is an example of having a default argument. So now if you go ahead and say print pizza of just the word pizza, then it would go ahead and fill in yum for t, right? So it'd say pizza and concatenate it with the string ... yum, right? But then if you specify both arguments, it'll use your parameter rather than the default parameter. The only time the default parameter gets used is if you don't specify something for that particular argument, right? So hopefully that's clear to you. And then we also said that if you have any inputs that don't have default values, so any inputs for which parameters are required, those need to come before any parameters that can take default values. So hopefully that's clear to you. And then we also said that you could go ahead and name these things, right? So you could say print pizza of s equals, right, pizza, right, and then something like that. And so then that would be no problem at all. And so that's just a little bit more formal, right? And so then you can go ahead and run that line of code. And then I guess our doc strings are still unbalanced, so I'm just going to go ahead and delete that. And then you would go ahead and we're printing a bunch of numbers, right? But you would go ahead and gee, I'm printing a little too much code here, right? But print pizza, right? So pizza ... yum, pizza ... yum. So that's what these 2 lines are corresponding to these 2 lines. And then print pizza of pizza is so delicious. That would be pizza is so delicious because it would concatenate these 2 strings instead. And then we have this logical thing. So I wanted to show you another example where we have a star, right? So this is an example of basically how we can pass in an arbitrary number of inputs to a function, okay? And so basically it would be parsed as a tuple. So it would be treated within the body of the function as a tuple. So if you say c of 0, that would mean the first argument to the function after a and b. So really it would be the third argument to the function because it would be after the first 2, right? It's c of 0. So c refers to everything else after the first 2 inputs, right? And you can see if a here. So what does that imply to you? Well, that implies to you that a is a Boolean. So a has to be a Boolean. It's a true or false value. Same with b, and same with c of 0. So same with at least the first argument after the 2 that were initially specified. So the first 3 arguments to logical have to be Booleans, and then it doesn't really seem to matter what data type the rest of any other arguments that are being passed in are, right? So you could have called this 56 down here, right? But it really only depends on the first 3 arguments because you're looking at A, B, and then C of 0, okay? So if you say logical of true, true, false, 56, false, right? So then these 3 arguments are passed in as C, right? And so if you say if B, you know, and so here, so if A, right, A is true. So if we look at if B or C of 0, right? So here B is true, right? So we would go ahead and return true, and that's why you see true printed on the console. But then if you see logical of false, false, true, well, now we have to look at the else statement because A is false. And then it says if not B and not C of 0, right? Then you would return int of true. But here this Boolean will be false, right? Because not C of 0 is false, because C of 0 is true. So hopefully that's clear to you. So that's why we return false there, right? But this would have returned 1. Remember, we said int of true is 1. And then this would have returned 0, right? We said int of 0, int of false is 0. Okay, so hopefully that's clear to you. And then we need to talk a little bit more about this keyword arguments, right? So basically what we would do, so this was an example from the previous video. I'm just going to go ahead and delete these examples. So you should go ahead and look at the previous video for more examples if you want to see a little bit more of that. But we could also have the keyword function. So what this does is basically we're going to have one concrete input A, okay? And then basically the star B means that there are going to be other inputs that are going to come in. And these are going to be parsed as a tuple, okay? So basically the A, B, C, D, and E here, there you don't have any assignments. They don't have any keywords on them. They're just simple inputs that are being passed into the function. And since they're separated by commas, Python will parse them as a tuple. And so that's what the star B means. So B is a collection of comma separated inputs, right? And so according to this function, this keyword function, the length of B would be the number of comma separated arguments that you have after A, after you pass in A. So storm wouldn't count, but these 5 would count. The question is, what happens with the star C? So this is an example of what's called keyword arguments. And so it's a little hard to explain, but basically what you could do is you could say keyword arguments are basically key value pairs that are passed into the function when the function is called. Okay, so then at that point, you would then be able to parse those key value pairs, those basically assigned variables, you know, because you can see that variables are being assigned here and they're being passed into the function. So winter is being assigned to a tuple with 3 strings in it. Spring is being assigned to another tuple with 3 different strings in it. So hopefully that's clear to you. But basically, you would then be able to parse those key value pairs, those assigned variables being passed in as a dictionary. Okay, so we said that if you have 1 star, these would be comma separated values, and those would be parsed as a tuple, right? So then these A, B, C, D, and E, these will be passed as a tuple. These are not key value pairs. Those are just elements. These are simple inputs that are coming into the function, right? And so this function is just going to count the length of that tuple, the number of these comma separated values. But then the rest of this stuff, this star C, means that for any other values that come in as key value pairs, so any other keyword assignments that you make and you pass in at the end of the function, I want you to treat that collection, that comma separated collection of assignments that you made as a dictionary. So basically it parses these last 2 inputs, this winter equals this tuple, spring equals this tuple. It parses that as a dictionary. So it says that C is a dictionary where one of the keys is winter and the value corresponding to it is the tuple December, January, February. And then another one of the keys in that dictionary is spring, and then the value associated with it is the tuple March, April, and May. Okay, so what's the length of that dictionary? Well, it's 2. There's 2 key value pairs coming in here. Okay, so that's why I said 2 here. There's 2 key value pairs that we made. And so this would go ahead and add 5, because that's the length of this string, to 5. That's the number of comma separated simple inputs that came in and were parsed as a tuple. The length of the tuple is 5. And then we have 2 assignments that we made. So 2 keyword arguments. These are called keyword arguments, and it's when you assign a value to a variable and you pass it into the function. And so if you say star C here, it tells Python to treat that arbitrarily, to treat the entire remaining contents as a dictionary. And then you could go ahead and get values out of the dictionary. Remember, we talked about C.items, right? And we said that's a dictionary. We said that's a generator, right? And then C.keys and C.values, right? Those are generators that belong to dictionaries. So you should go back to previous videos and review some of those things. But then if you go ahead and look at this code, right? So you could go ahead and, I guess I'm printing a lot of different things here, right? But then you would go ahead and print 110, right? Because let's go ahead and run this. I don't know if this is completely updated. So 12, right? You would go ahead and print 12 because you have 5 plus 5 plus 2. So you go ahead and get 12. What if you run it with a different input, right? So here the length of A is the number of distinct elements in this set. So that would be 9. right? And then you would have the number of comma separated values coming in. So you have a string and then a tuple, so that's 2. So 9 plus 2 is 11. And then you have 3 more key value assignments that you make. So 11 plus 3 is 14. So hopefully that makes sense to you. That's called keyword arguments, and hopefully that's clear to you. We'll review a little more in the next video. From UMOS 03, thanks for watching, and please subscribe.